Hello, my name is Orrego. I work with the Metropolitan North Georgia Water Planning District as the group's senior GIS and data analyst. Today, I will be highlighting GIS techniques for assessing water supply watersheds and protecting source water. First, I would like to go over what exactly the Metropolitan North Georgia Water Planning District is. And because that is such a mouthful, you will hear me refer to us as the Metro Water District for short. The Metro Water District was created in 2001, so this year marks our 20th year anniversary. We are staffed by the Atlanta Regional Commission, and we cover water resources planning for 15 counties and 95 cities. Our main role in regional water planning is facilitated through the implementation of a long-term, comprehensive water resources management plan. Adherence to this plan and implementation of it is required of all water providers in the district and is enforced by the Georgia Environmental Protection Division, it's Georgia EPD. And this picture here displays our most recent 2017 Water Resources Management Plan, and it's updated every 5 years. Action Item Integrated 6 of that 2017 Water Resource Management Plan requires local water providers to develop a source water protection plan. That delineates raw water sources and identifies the potential sources of contamination to drinking water. So, in order to provide support to our jurisdictions in this effort, we as a district contracted with GIFA and Georgia EPD to update source water assessment plans, and I'll refer to these as SWAPs for short. But SWAPs for each surface water withdrawal location in the district. Essentially, this means if you as a water provider have a surface water intake on a lake, river, stream, or reservoir, we delineate the entire watershed that would drain into your source waters. So this entire watershed here. And all that water that would essentially run through the land and drain to those source waters, and then eventually reach your intake. So this creates your water supply watershed. Then we gather data on facilities that could be potential point sources of pollution, such as airports, gas stations, landfills, mining operations, things of that nature, and as well as non-point source factors such as percent impervious area, land cover, land use, major roads or railroads crossing streams, and we map them out throughout the watershed, determining the risk they pose if pollution or contamination from the facility or nearby location were to reach surface waters and eventually reach the surface water intake. This then determines the ranking of susceptibility of the water supply watershed to contamination. So I just want to highlight that each score per management zone or water supply watershed, same thing here, management zone and water supply watershed, are a ranking of potential susceptibility if pollution from a site were to occur. We're not saying that it is currently occurring. So this essentially is just determining that risk. In this effort, we have been updating nearly 20-year-old SWAPs for 26 water providers or systems, which translates to 42 surface water intakes, and that results in an analysis and assessments for 39 management zones or water supply watersheds. So as you can see, a lot of work went into updating all of these reports, and it covered a wide range of area in the Metro Atlanta region and even in the North Georgia region. So that was just a basic overview as to how we got started on this project and why. And now, to understand the susceptibility to pollution determination, we considered two different types of potential pollution drinking water intakes are susceptible to, and that's individual sources. So this is similar to like a point source, but because these facilities aren't actually providing point source pollution at the exact moment, they're just a risk of providing it. We call them individual sources for this study. So individual sources and non-point sources are the two different types of potential pollution we look at. So individual sources involve distinct facilities which have contaminants on site and can pose a potential health risk if humans consume those contaminants. And then non-point source come from runoff reaching water supply. The way we quantify and assess the different potential pollution types differ. First, we'll discuss individual source susceptibility determination on the next slide. So here we address two issues for which intakes are susceptible to as far as by individual sources, and that is the release potential for that contaminant to reach surface water and eventually travel down to the intake. And second is the risk potential, which is the risk the contaminant poses to drinking water supply if it were to reach the intake. And we take a look at different types of facilities at varying zones of significance. These zones are identified as the inner management zone, IMZ, which is the 7-mile radius watershed area from the intake, the outer management zone, OMZ, which is the 20-mile radius area from the IMZ, and then the NMZ, which is the remainder of the watershed past that 20-mile radius. And I'll show you what that looks like on a map here soon. So table 1 lists potential individual pollution sources that must be evaluated in each of the 3 management zones according to EPD guidance. A more stringent assessment of sources is conducted in the IMZ and OMZ, you can see here, then in the NMZ. And that's due to the larger distance from the NMZ to the intake itself, which is greater again than 20 miles upstream. So you can simply think of this as the closer to the intake you are, or your facility is, the more stringent the analysis and the more facilities or potential individual sources of pollution we identify, track, and assess. So here's that mock example I was referring to earlier of what those management zones would look like within the water supply watershed. So you can see the IMZ in the green line here. So that would be 7 miles from the intake. And then we have the OMZ in yellow, while everything within the watershed past the yellow is the NMZ. So this extra area here is the non-management zone. And depending on the size of the water supply watershed, you may have a non-management zone and you may not. Again, it just depends on that size. Now we get into the details of actually assessing each individual source for its risk and release potential using this matrix. In order to assess potential risk, we determine a 1 to 3 or low, medium, or high rankings. So here, 1 means low, 2 means medium, 3 means high, for distance to intake and toxicity of the contaminant. Then we assess low, medium, or high, again 1, 2, or 3, for the distance from surface water, volume of release, the duration of that release, and then the ease of transport or travel, determining that individual source's release potential. So, each facility will get a risk ranking of 1, 2, or 3, and then they'll also get a release ranking of 1, 2, or 3, and that will determine where they place here on this matrix. The highlighted calculations in yellow are for which I will show GIS techniques for assessing and quantifying. So that's distance to intake, distance from surface water, and then ease of transport or travel. Specifically, I'll go through a few updated rankings and calculations that we specifically modified from the original EPD guidance. And again, that's distance from surface water, where the ranking and calculations were modified. Distance from water intake remained unchanged, so we did not change this. We just changed the methods for calculating it. We didn't change the methods for calculating this. We were just going to display what GIS techniques we used to calculate that. And then we actually added slope and land use land cover class. So this was not in the original EPD guidance, but we added these two in order to enhance ease of transport and to calculate that more effectively. As you can see here, ease of transport incorporates distance from surface water plus slope plus land use land cover. So we could kind of get a full picture, a comprehensive look of how exactly that contaminant could travel and how easily it could travel to the intake. So now we'll go over some GIS steps to measure the distance from stream, so the distance that facility is from the nearby stream. And here we calculated it based on elevation flow paths from each facility to the nearest stream. The required data in order to do this calculation exactly the way we did is you'll need that facility location, so that'll be in point file. The USGS digital elevation model clipped to the watershed itself. And you can download that easily through USGS. And then the stream layer that we created using the DEM. And once you have those three layers, the steps in order to calculate this, we use the elevation raster with the flow direction tool to generate a flow direction raster. Based on that flow direction file, as well as the elevation and stream rasters, we generate a flow distance raster for which each pixel value approximates that horizontal distance along the flow path from the point to where it intersects the stream. For each point shapefile, we extract the distance from stream raster values to its points. These flow paths from each individual source to the nearest streams were calculated in ArcGIS Pro using the flow distance tool. The flow distance outputs, again, the horizontal length of the natural flow path to the nearest stream in decimal degrees, and then we converted those decimal degrees to feet. So here is just an example of a reclassified elevation raster clipped to that water supply watershed with the stream network included in that. And then we created that flow direction raster, which is then used to produce that flow distance to that nearby stream. So the range of median distance to surface water values calculated across the 25th, 50th, and 75th percentiles was 1,440 feet, being a high ranking, so it's close. That facility is close to nearby surface waters. 2,339 feet was medium, so in between 1,440 to 2,339 feet, you would get a medium ranking. And then if you were anywhere further than 3,209 feet, then you would get a low ranking because your facility is far away from that nearby stream. The distance from each point to the surface water intake, more accurately the mouth of the watershed boundary, was calculated using a model in ArcGIS Pro that created cost paths. These paths follow the cheapest cost path in a given region from a set of raster or column and row pixel data that follows a reclassified 10-meter resolution national elevation data set. Again, that's that USGS NED elevation raster, as well as a flow direction raster generated from that same NED using the flow direction tool. A path is generated for each potential pollutant source after it has been snapped to the stream. So once we figure out that exact location it'll enter the stream, we'll snap that point there using the near tool, and then we merge it into a final polyline feature class before the original stream points are spatially joined to the lines so that the links are associated with their respective potential pollution sources. Excuse me. This can be done for individual points easily by using the proper tools in correct succession for entire watersheds when placed in a model. So again, cost here just refers to the values at the raster pixels and determines how costly it is to move to the next pixel. Lower values are cheaper. The flow direction and elevation values allows the paths to follow the region's topography downhill, perfectly aligned with the streams themselves. So you can see kind of a depiction of this, right? So all of those little dots are facilities that have been snapped to where they would be entering into the stream. And so on the left, we have all those points snapped to the flow direction raster, and then the elevation raster. And then on the left, on this screen, you can see all of the calculated flow lengths from point to intake in red. And on the right is an example of 2 individual flow lengths. So here's one in yellow from 2 particular facilities. So the one in yellow and the one in red, right? So the one in yellow is much longer. So we're calculating the distance it would take for a contaminant from a facility around this area to actually reach the intake, which is pretty far. And then again, a facility around this area from the intake. These lengths were then ranked based on the following classifications. So again, we didn't change these classifications. It was taken straight from the EPD implementation guidance, and we followed that. Next, we discuss ease of transport. This is simulating how easy it would be for the contaminant to reach surface waters if a pollution event were to occur. So it was calculated by taking the average of the determined ranking values for distance from surface water, so we just saw that, slope, and land use land cover, or LULC, for each point source facility. The elevation difference was calculated by taking the difference between the elevations at the starting point and ending points of the flow path, calculated again using that flow distance tool in ArcGIS Pro. Slope was then calculated by dividing the elevation difference by the flow path distance for each point source facility. The range of median slope values calculated across the 25th, 50th, and 75th percentiles were 0.006, 0.009, and 0.012 respectively. LULC classes from the National Land Cover Dataset, again we got this dataset online, were reclassified from 15 to 8 classes. So you can see the 8 classes that we used here. As many of the original classes of the 15 were not relevant for the study. The LULC weight was calculated in ArcGIS Pro by taking the average of all pixel classes along the straight line distance between each point source facility and the nearest stream. Ease of transport rankings results in the average of the 3 category rankings. So again, that's distance to stream, land use, land cover, and slope. Distance from surface water, slope, and land use, land cover. The remaining rankings of toxicity, volume of release, and duration of release were determined based on generalized rankings categorized by the type of facility and other available information. And you can see how we generalize those here. Once every single individual source underwent risk and release potential assessment and was plotted on the matrix, the overall individual potential susceptibility score could be calculated. We did this by applying a weighted average that is also based on the size of the watershed. This allows us to take a closer look at the number of potential point sources of pollution, their priority, so high, medium, or low, and compare it to the overall size of the actual watershed. We then created ranking thresholds by comparing all 43 of the watershed rankings. So here's just a depiction again of that matrix, and then this is the formula we used in order to create kind of that weighted average to incorporate this actual size of the watershed. And here are those ranking thresholds. Nonpoint source pollution susceptibility score was determined based on percent impervious area in the watershed. Although numerous other metrics were calculated and assessed, such as land cover, land use, effective impervious area, sewered area versus non-sewered area, sewer lines, crossing streams, major roads, crossing streams, etc., those were not used to actually rank the watershed's susceptibility to non-point sources. We strictly use that impervious area, and research has shown that these thresholds best represent the health of a watershed based on the percent impervious surface in the watershed area. So more than 10% shows significant of impervious area shows significant impacts on watersheds, and anything over 20% shows rapidly deteriorating effects on the watershed health. So once both the individual and non-point source score of low, medium, or high are calculated, they are combined to reduce the overall watershed susceptibility to contamination. Local water providers are then required by that water resources management plan we mentioned early on to publish the results in their consumer confidence reports. These reports are now released twice a year by every water utility to inform the public on their water quality and their federal compliance. They then must integrate this information into their local emergency water plans, and finally update swaps every 10 years thereafter. These reports can be really useful in informing emergency response plans so that if a spill were to occur, utilities and local emergency response personnel are sufficiently prepared to manage and mitigate the issues before it causes harm to human health or results in large costs to water treatment plants to remediate. Again, consumer confidence reports help jurisdictions target vulnerable areas for protection, and update and inform their consumer confidence reports. And these swaps help jurisdictions target vulnerable areas for protection of their source waters. Because the cleaner the water is before it enters the treatment plant, the cheaper and easier it is to treat it and send it out to the public for drinking. If you would like to find the summary report of the results and the methods for the 2020 swap update, you can go to northgeorgiawater.org, click on Conserve Our Water, then click on Water Supply in Our Region, and it's located right here. So if you click right here, it'll take you to that report. We also have a link here for anyone's convenience. I would like to give a special thanks to my special assignment staff, Shelby, Nick, Jefferson, Michael, Cheyenne, and Corin, who made all this work possible. They were a great team to work with. And also GIFA and Georgia EPD. Thank you. I'm happy to take any questions.